If we take a look at the first pair of triangles on the screen, we can see that they have two pairs of congruent angles. They have the two 60-degree angles and the two 70-degree angles. And if we add up the 60-degree angles and the 70-degree angles, and we subtract the sum, which is 130 from 180, since all three angles of any triangle add up to 180, we'll see that the remaining angle has to be 50 degrees in both of the triangles. These two triangles here have three pairs of congruent angles, so we can say that they're similar to each other by AA. As long as two pairs of angles are congruent, two pairs of corresponding angles are congruent, the third pair of angles also has to be congruent as well. Two pairs is enough to show that they're similar by AA. In the second pair of triangles, if we take a look, we can see that to get from the small triangle to the big triangle, each pair of sides is multiplied by 2. And if we wanted to see what that scale factor is, we could take a side from big triangle and divide by the corresponding side from small triangle to see that that scale factor is 2. The scale factor is the same for all three pairs of corresponding sides, so we can say that these two triangles are similar by SSS. And finally, in the third example over here, if I want to see if the corresponding sides are proportional, I can take the corresponding sides and divide side from big triangle over corresponding side from small triangle, and I get 3 over there. And I can do the same thing with the other pairs of corresponding sides as well, so I can see if they have the same scale factor. And I see here that the sides are in fact proportional, so these two triangles are similar by SSS. Notice how they also have a congruent pair of angles, so we could also say that they are similar by SAS. To be similar by SAS, there needs to be two pairs of proportional sides with a congruent angle in between. So here we do have enough information for either SSS or SAS. There is one more way of proving triangles similar, and it does come from AA. Here in each of the triangles, because I have three different examples here, I have a segment that is parallel to the base of the triangle. And since it's parallel to the base of the triangle, we have congruent corresponding angles between the small green triangle and the big purple triangle. We also have an angle that's shared between the two triangles. This angle at the top is in the small green triangle, and at the same time, it's also in the big pink or purple triangle. So we do have AA, so we have two similar triangles. And this is going to happen anytime we have a triangle that has a segment parallel to the base. We'll form a smaller triangle that is similar to the original big triangle. And I'm going to put here the symbol for similar so that we have that there. If a line is parallel to the base of a triangle, it forms a triangle similar to the original triangle. Over here, we have an example. It's mentioning triangles ABC and DEF, and I don't see them here, so I'm just going to draw them. Triangle ABC and triangle DEF. And it tells us here that AB is 4, AC is 5, DE is 8, DF is 10, and angle A is congruent to angle D. And it's asking us what method to use to prove triangles similar to each other. Well, it's looking like SAS because we have information about two of the sides and a congruent angle in between. But in order to be SAS, we do need to tell if the sides are proportional to each other. So I am going to do side from big triangle divided by corresponding side from small triangle so we can see what the scale factor is. And I'm going to do the same thing for the other pair of corresponding sides so we can see that the scale factors are the same. They are in fact the same, So they are proportional, and the triangles are similar by SAS. We could have eliminated answer choice 4 right away because ASA is not one of our ways of proving triangles similar. That is only a way of proving triangles congruent to each other. Over here, we have another example. It's asking us which method could be used to prove triangle PST similar to triangle RQT. Now already, I can eliminate answer choice number 3 because once again, ASA is not a way of proving triangles similar. It is only a way of proving triangles congruent. In the question, it also tells us that PS is parallel to QR, so I'm also going to put that in the diagram. Now that I have parallel lines, I'm thinking parallel lines cut by a transversal. And notice I have a letter Z. And when we have a letter Z, in the corners of that letter Z are congruent alternate interior angles. Remember, alternate interior angles are congruent when parallel lines are cut by a transversal. There's also another pair of alternate interior angles over here as well, because there's another Z that's formed. We also have congruent vertical angles. We have here that the two triangles are similar to each other by AA. We have two pairs of congruent corresponding angles. In fact, in this question, we could have also ruled out answer choice 1 and answer choice 2 because in order to have SAS or SSS, sides would need to be proportional. And since we have no numbers in this question, we actually can't find the scale factor to determine if the sides are proportional or not. So if we have no numbers, AA is always going to be the way to go for how the triangles are similar. Over here, we have AB is 6 and AC is 8, and they already tell us in the question that the two triangles are similar to each other. And it's asking us which statement will justify similarity by SAS. So for SAS, since I already have information about these two sides, what I need is I need the angle in between. So that would be angle A, and that would correspond to angle D over here since A is the first letter and D is the first letter. Those angles correspond. So I need to find the answer choice that has angle A congruent to angle D, and that also puts measurements here that are proportional to the measurements that I'm already given here. So already, I'm going to eliminate answer choice 3 and 4 because that doesn't have the angle in the correct spot. So now all I need to do is check out answer choices 1 and 2 and see which ones have side lengths for DE and DF that make proportional to the other side lengths on triangle ABC. So in answer choice 1, it's saying DE is 9 and DF is 12. So let me find the scale factors. I'm going to do side from big triangle over corresponding side from small triangle. That's 9 over 6, which is 1.5. And I'm going to do the same thing with the other two sides, 12 over 8. And that is 1.5 as well. So since there's the same scale factors, the sides are proportional. So answer choice 1 is the answer choice that we are looking for. Two proportional sides with a congruent angle in between, SAS. Okay, moving along over here. They tell us in this question that AB is parallel to DE. So already from that, I see that we have the congruent alternate interior angles once again, and we have congruent vertical angles like we had before. We already know that the triangles are similar to each other by AA. Now that we know the triangles are similar, that's going to help us in the question because when we have similar triangles, corresponding sides are proportional, and we can set up and solve a proportion in order to find missing side lengths. They tell us that CD is 6.6 centimeters, DE is 3.4 centimeters, CE is 4.2 centimeters, and BC is 5.25 centimeters. And what we're looking for is the length of AC to the nearest hundredth of a centimeter. So I'm going to represent AC as X. What I want to do here is I want to set up a proportion since the triangles are similar and their corresponding sides are proportional. I definitely want to have X in my proportion because I'm looking for that. And I'm going to use the corresponding side to X, which is CD. So on the other side of my proportion, I have to set up the same way. Over here, I did a side from the bigger triangle over its corresponding side from the smaller triangle. So I have to do the same setup over here that I did on the left in order to be consistent. So I'm going to take another side from the big triangle that I have information about, which is 5.25, and its corresponding side from the small triangle, which would be 4.2. And from here, I'm just going to cross multiply. We have 4.2x is equal to, oh, here I wrote CD. I didn't put the measurement. Let me replace that with the measurement of CD. That was 6.6. And over here, we have 6.6 times 5.25. 34.65. From here, we'll just divide both sides by 4.2 so that we can get our x value. And I got that x is equal to 8.25. Side AC, which is what we are looking for. So that is our answer here. Moving on to the next question over here. They tell us that angle D is 65 degrees. Angle CBE, this one right over here, you can't see E. Here you go. Now you can see E is 115 degrees. DC is 7.2. AC is 9.6. And FC is 21.6. And we need to find the length of CB. So I'm going to represent CB as X because we're looking for it. I want to set up a proportion in order to find the missing side length. But in order to set up a proportion, I have to know that the sides are proportional. So I have to know that the triangles are first similar to each other. These two angles here are supplementary. I'm going to do 180 minus 115, and I got 65 degrees. So I see that this angle over here is congruent to this angle in the other triangle. And I also notice that we have congruent vertical angles. So we do have pairs of congruent angles. So the triangles are in fact similar by AA. Now that we know the triangles are similar, we can set up a proportion to find the missing side. So I definitely want to have x in my proportion because I'm looking for that. And that's from the big triangle. So I'm going to use the corresponding side to it from the small triangle, which would be 7.2. So I have big triangle over small triangle. So I have to be consistent over here. I have to set up the same way. So I'm going to take another side from big triangle. The only other one I have information about is 21.6. And the corresponding side to it from the small triangle is 9.6. From here, I'm going to cross multiply. 9.6x is equal to 7.2 times 21.6. And I got 155.52. And from here, I'm going to divide both sides by 9.6. And I got x is equal to 16.2. And 16.2, x is the length of CB. So that is the answer that we are looking for. That is the length of CB. Moving on over here, we have a smaller triangle, SYZ, inside the larger triangle, SRT. And they tell us already in the question that the two triangles are similar to each other. And we need to find the length of YZ. So YZ is already represented as 2x plus 2. So we need to find the x value so that way we can plug in and see what that side length actually is. So since we know the triangles are similar, we know that the corresponding sides are proportional, so we can set up and solve a proportion in order to find the missing side length. So I'm going to start with the side that we want to find. That's the small triangle, 2x plus 2. And I'm going to use the corresponding side to that from the big triangle. YZ is the first and third letters in this triangle's name. So we them out the first and third letter in the triangle's name, which is RT, 3x minus 7. Since I did small over big here, I have to be consistent on the other side and set it up the same way. So I'm going to take Another side from small triangle, careful, ST, the whole side from big triangle is 40. So the side that corresponds to ST from the small triangle, ST is the second and third letters, SZ is the side that corresponds from the small triangle. So that would be the whole 40, take away this 5, that would be 35. And then the full side from the big triangle is 40. And then from here, we can cross multiply. We're going to do 40 times 2x plus 2 equals 2. 35 times 3x minus 7. From here, we're going to distribute the 40 inside the parentheses. That's 80x plus 80. And over here, we're going to distribute the 35 inside the parentheses. That's 35 times x, which is 105x. And then 35 times negative 7, which is negative 245. From here, I'm going to add 245 to both sides. And then I'm going to subtract 80x from both sides. And then finally, I'm going to divide by 25 to get x by itself. And I get that x is equal to 13. So remember, we're looking for yz. So I'm just going to plug in the x value into the expression for yz. So 13 times 2 is 26, plus 2 is 28. So the length of yz is 28. Over here, we have a question that deals with proportions. We're told in the question that AC is parallel to BD. So once again, we have the congruent alternate interior angles. Let me make that a bit neater. And we have the congruent vertical angles. So we know the triangles are similar by AA. So now that we know the triangles are similar, we have to see which is a correctly set up proportion. It's going to be correctly set up if it puts the corresponding sides together. So let's go through one by one. In number 1, CE is a side from big triangle, and DE at the bottom is a side from small triangle. Let's just make sure CE and DE correspond. Second and third letters, second and third letters. Good so far. Since this is big over small, this side should also be big over small. EB is from the small triangle, so that does not work. It should be big over small equals big over small. If it's set up one way on the left, it's got to be set up the same way on the right to be consistent. Let's check out the next one. AE is from the big triangle, so once again, we're starting off with big triangle. And BE is from the small triangle. Let's make sure these correspond. First two letters, so far so good. Since this is big over small, this also needs to be big over small. AC is big, BD is small. Let's make sure these correspond. First and third letters, all good to go. Answer choice 2 is a correct equation. We can check out 3 and 4 to see why they're incorrect. EC is from the big triangle. AE is from the big triangle, which is fine. These just need to be the corresponding sides to these from the small triangle. Let's see if EC and BE correspond. Second and third letters, but BE is the first and second letters, so these don't correspond. That's why that one's not correct. And answer choice 4, ED is from the small triangle. EC is from the big triangle. Let's see if these correspond. Second and third letters, good so far. So this side should also be small over big. But already I see AC is from the big triangle. That is not correctly set up. Moving on over here, it tells us here that angle C is congruent to angle OTU. And since we have the smaller triangle inside of the big triangle, it's going to have a shared angle, and that shared angle is angle U. Notice how angle U is inside the small triangle, and at the same time, it's also inside the big triangle. So we can say it's congruent to itself by the reflexive property. So now that we know the triangles are similar, we need to find the missing side length. They tell us that TU is 4, that OU is 5, that OC is 7, and we're looking for the length of ST. So I'm going to label that X. The problem is that the triangles are facing in different directions, and they don't give me both of the triangle names. They give me triangle SCU, which is the big triangle, but they don't give me the name of the smaller triangle, so I can't correctly match up the corresponding parts from the triangle names. So what I'm going to do is I'm going to redraw both of the triangles so that they're facing the same way and so that their corresponding parts match up. So what I'm going to do is I'm just going to draw them both with angle U at the top because they share that angle. So angle U has to correspond in both the big and the small triangles because that's the angle that they share together. So I'm not a good artist, so this is not going to look right. But I'm redrawing them both so that the shared angle, angle U, is at the top. Now, also, in both of these triangles, they have a congruent angle, angle C and angle OTU. So since those angles are congruent in the similar triangles, that means that those angles must correspond to each other. So angle C in the big triangle, wherever that is, I'm going to put it over here on my triangle, needs to match up to angle T on the smaller triangle. And then that leaves O over here and S over here. So now I'm just going to relabel the triangle lengths now that I have the triangles drawn the same way. TU is 4, OU is 5, OC I can only see on here because it's not a full side of the triangle, it's a piece of the side of the big triangle. So together with the side from the small triangle, the whole side from the big triangle would be 7 plus 5, which would be 12. And I can put that over here, CU is 12. And they also ask us for the length of ST. But ST is not on either of these triangles because once again, it's just a piece of the side of the big triangle. So if we can find SU, so I'm going to label SU as the question mark. If we can find SU, then we can select a 4 and we can get ST, which is what we actually want. So now I'm going to set up a proportion now that I know which sides correspond. And I want to find this side, and it corresponds to this side. And I also have this side, and that corresponds to this side. So I can cross multiply. I'm just going to label that as x. So 4x equals to 12 times 5, 60. And then divide by 4 on both sides, and we get 15. But that is not the answer because that's this whole side from the big triangle SU. We need to find ST. So if we do 15 minus 4, we get 11, which is what we're actually looking for. We're going to do one more question in this video. So over here, we're told that in this in triangle ABC, ATV is equal to angle ABC. And notice how we also have a shared angle between the small and the big triangles. We already see that the small and big triangles are similar to each other by AA. They tell us that AT is 4, that BC is 18, that TB is 5, that AV is 6, and we need to find the perimeter of quadrilateral TBCV. So in order to find the perimeter, I need the side lengths. So I already have this side and this side, but I need this side and this side. So I'm going to label this one as X and this one as Y. And that's what we're trying to find over here. So portions using the sides of the smaller triangles, small and big triangles. So I want to find here x. And x is a side from the small triangle, and it corresponds to 18 from the big triangle. And another side from the small triangle is 4, and it corresponds to AB, the whole side from the big triangle, which is 9. So I'm going to cross multiply. 9x is equal to 18 times 4, which is 72. I'm going to divide both sides by 9, and I get x is equal to 8. So I'm going to replace over here x with 8. And now we just need one more side of the quadrilateral in order to find the perimeter. We need this side that's labeled y. But this side is not a side from the big triangle. AC is. So I'm going to have to find AC because that's a side from the triangle. Subtract off 6 once I have it, and that will give me the side that I actually need from the quadrilateral. So let me make an equation to do that. So I'm going to use 6 from the small triangle, and the corresponding side to it from the big triangle is AC, which I want to find. I labeled that as Y. And then I just need another side from the small triangle and its corresponding side from the big triangle. I'm just going to use 4 and 9 again, like I did in the last proportion. From here, I'm going to cross multiply. 9 times 6 is 54. And then over here, we have 4y. And we have y is equal to 13.5. So this whole side over here of the big triangle is 13.5. So I can find the side from the quadrilateral that we actually need. Now that we have all four side lengths, 7.5 plus 8 plus 5 plus 18. So all four sides of the quadrilateral at the bottom to get the perimeter of the quadrilateral, which ends up being 38.5.